Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Faris Hanudiyarso. My absent number is 32101811023. I'm from Power Plant Engineering from Electronic Engineering Polytechnic Institute of Surabaya, and I will explain my final project proposal with the title is Analysis the Effect of Jet Imbalance Distance on Double Trapezoidal Absorber Plate Solar Air Heater. With the supervisors ones is Mem Radina Anggun Risma SPD MPD, and the supervisors two is Mem Lodidiana STMT. Next, background of research. The use of solar energy can be applied to many things, one of which is the use of a solar collector or solar emitter in the drying field. This tool utilizes solar energy in the form of radiant heat transfer, which is then absorbed by a heat absorbing plate, which then exchange heat with the working fluid in it. The working fluid on the solar collector can be water or air. One of the problems that occur in the solar emitter or solar collector is the low rate of convection heat transfer between the surface of the absorber plate and the air flowing on the top and bottom sides. This makes a lot of research conducted with the aim of increasing the efficiency of SAS. Modifications made to increase the thermal efficiency of solar air heater are to increase and expand the area of the absorption area of heat energy. There are various types of modification, like the addition of planes, fins, obstacle, vortex generation on the SAH. After adding the plane area, the researchers also made variations for the area that had been added to SAS, namely in terms shape, angle, size, or distance in the SAS installation, especially on the absorber plate. Then there are other ways to improve the performance of SAS apart from adding and modifying the absorber plate material, namely by providing holes or gaps, namely jet imbalance. Jet imbalance or jet imaging flow is a heat transfer method in which the fluid is emitted through hole or nozzle to a surface or plate that has a temperature difference. Imaging in here means collisions, which is collision between the coolant and the surface of a target at high flow rates. In addition, this method can also be used to heat a component or curtain material, for example, in the paper drying process. Based on the background of research, in this final project, a research will be conducted on the provision of jet imbalance on SAS, which has two trapezoidal absorber plate arrangement, or by other name is double trapezoidal absorber plate solar editor, or DTAP-SAH, with the title Analysis of the Effect of Jet Imbalance Distance on Double Trapezoidal Absorber Plate Solar Editor. The analysis in this final project is carried out numerically by modeling DTAP-SAH in computational fluid dynamics simulations and experimentally by making DTAP-SAH and testing its performance in the laboratory with measuring instruments. The purpose of writing this final project is to find out whether the distance between jets imbalance affects the performance and efficiency of DTAP-SAH. Problems. Based on the background of the research, the problem can be formulated as follows. First, how does the jet imbalance distance affect the DTF-SAH heat transfer rate? And the second, what are the characteristics of the airflow in DTF-SAH? And number three is, how is the performance and efficiency of DTF-SAH after being given variations of the jet imbalance distance numerically and experimentally? And goals of final project is, first, knowing the rate of heat transfer in DTAP-SAH with variation in jet imbalance distance. And number two, knowing the characteristic of the airflow produced by DTAP-SAH. And number three, knowing the performance and efficiency of DTAP-SAH numerically and experimentally based on variations in the jet imbalance distance. Some of the limitations taken in this final project are, first, DTAP-SAH performance analysis was carried out at steady state condition. The second scope of problem, the material used for the absorber plate is aluminum. And the third, data collection is carried out in the laboratory using halogen lamps instead of sunlight or artificial solar. And the last is the electrical system on the tool is not counted. In this previous research, I will use 6 previous research. The first and second research about the trapezoidal solar air heater. The difference is the first using radiation intensity of sun, and the 2 using halogen lamps, and the 3, 4, and the third and fourth research about the jet impingement in solar air heater, and the fifth and sixth research about the jet impingement performance in CFD. And this is the research flowchart. The first step is literature study of corrugated solar aerator plus jet imagement, and then design and configuration planning of jet imagement on DTAP-SAH. And the next is geometry design for adding jet imagement to DTAP-SAH using GAD software. And then the research, there are two studies. This is numerical studies and experimental studies. The first step of numerical studies or flowchart. But the first is DTLP-SAH, modeling with jet impingement using CFD, and then performing the meshing process, boundary condition, and simulation setup, and then processing stage. And the step of numerical flowchart is determination of formulas and equation used for DTAP-SAH analysis based on literature, and then DTAP-SAH fabrication process with jet impingement, and then assembling supporting tools and measuring instrument on the finished GTAP-SAH. And for the numerical flowchart, there are grid independency. After that, we can do the DTAP-SAH simulation with variation in the distance of the jet imagement, and then there are simulation data retrieval. For the experimental flowchart, the process of collecting DTAP-SAH test data with variation in the distance of the jet imagement, and then we can processing and calculating data according to the formula and equation. After the two study is finished, we can making of data analysis based on numerical studies and experiment, graphing, and final project reports. Data required. Uh, there are 10 data required for the final project. There are cover glass temperature, absorber plate temperature, jet plate temperature, ambient temperature, inlet air temperature, outlet air temperature, inlet air velocity, room air velocity, halogen lamp radiation, and static pressure. Data analysis, and this is the detail of part component of DTAP-SAH. There are cover glass, absorber plate, jet impingement, asbestos cloth, glass wool, and this is the thermal resistance of DTAP-SAH, and this is the variations of jet impingement distance. There are three variations. The first is 56.25 millimeter, and then next is 112.5 millimeter, and then the next is 168.75 millimeter. And this is the experimental data. There are two variable control in the experimental data. This is mass flow rate and radiation intensity. Uh, there are the model one is the fixed mass flow rate with variation radiation intensity, and the model two is the fixed radiation intensity and the variation of mass flow rate. And then there are numerical data that get obtained from the CFD results. There are temperature distribution, temperature contour, velocity distribution, velocity contour, velocity vector, and the last is streamline of airflow. Hypothesis. In the study, the variation of the distance between the jet impingement was 56.25 millimeter, 112.5 millimeter, and 168.60 I'm sorry, 75 millimeter. Based on previous research, the large diameter of the jet affect the results of the outlet temperature on the SAH. Then the distance pattern between the jet impingement affects the velocity distribution and the resulting pressure distribution. Several studies have also revealed that corrugated plate with the addition of jet impingement will increase the rate of heat transfer and affect the efficiency and performance of the resulting SAH. Thank you for your attention.